This video introduces text is mass, modeling as stochastic embedding for text video retrieval. This work was accepted by CVPR 2024 with an highlight honor. For the text video data, we refer to long or short video clips. And the text can be in the form of caption, title, and hashtag, and etc. The general text video retrieval pipeline is to firstly encode text and video data into the joint embedding space, and then we perform similarity matching. We observe that in existing works, text and video are generally mapped as vectors in the embedding space. However, video contains redundant details, and the text in general is hard to fully describe the content of the video. So this naturally raises a question that can we make text features more flexible and resilient to better capture the video representations in the joint embedding space? Accordingly, we propose TMAS, which is text is modeled as stochastic embedding. So the input text is no longer mapped as a single point, but becomes a distribution in the joint embedding space. Accordingly, it no longer corresponding to a specific semantics, but incorporates a semantics range. This is implemented by reparameterization, as the equation shown here. And we use TS to denote the stochastic text embedding. We also propose a learnable radiance module R to control the scale of the text mass. Specifically, we refer to text-video similarity values as an indicator to help implement the radiance R. We also provide a linear layer to empower the learning of the radiance. For the loss function, we still adopt the symmetric cross-entropy, but we exchange the original text embedding T with the proposed stochastic text embedding TS. We also identify a support text vector T-soup to help further control the scale and the location of the text mass. Accordingly, we have a new loss regularization term of L-soup. So the total loss function is the weighted sum of LS and L-soup. We also modify the evaluation pipeline to fully take advantage of the proposed text mass. So given the input text T, we perform sampling for multiple times, and we choose the stochastic text embedding that has the highest similarity value with the video embedding. As for the final similarity calculation, we observe that the proposed TMAS outperforms the state-of-the-art methods on the dataset of MSR-VTT and LSMDC. We have similar observations on the dataset of Didimo, Vtex, as well as Charidas. Besides an encouraging text-to-video performance of the proposed TMAS, it also works well for the task of video-to-text retrieval. Here we provide an ablation study of the proposed method. You can clearly see the performance boost by different modules. We also discuss the impact of the radiance R, and we have following observations. Using text mass can generally result in performance boost, and the radiance R is relatively insensitive to different implementations. The linear implementation performs the best. We also visualize the evolution of the radiance. We find that the proposed method enables an accurate semantics learning, especially for the relevant pairs. We also observe that the proposed stochastic text embedding enables smaller cosine values for irrelevant text-video pairs and smaller loss values for relevant text-video pairs. We also discuss the number of testing trials, and we find that the sampling for 10 or 20 times enables stable performance. Please check out our paper, Code and Supplementary, by scanning the QR codes. If you have any questions, feel free to contact me via email or submit an issue on the GitHub repo. Thank you.